Hello everyone, good morning again. Am I audible to you?
Yes, sir.
Okay, fine. Okay, all of you please check your class group. Okay, I have given some link in YouTube videos for IELTS visitors. So please go through that videos for your better understanding. So now we are going to start one new thing. Okay, is there anyone having any doubt in the last things? If you have, you can ask. So we will discuss about these arches. Okay, so I think all of you know what is arch and how it is look like. So here it is showing a arch. Okay, this is the arch, simple diagram of arch. How it is, which part is called what. It is also showing here. It is. So we are going to discuss about this arch. Okay. So this is also statically determined structure because we are going to use the equilibrium equation. By solving the equilibrium equation, we will find out all the required data for this arch. So it is a two type. One is circular, one is parabolic. Okay. So we'll discuss both the structure, how we need to solve. This is a three hinge arc. Why it is called three hinge? Because it is hinged in 3 points. It is of two types, circular and parabolic. We will discuss about this in the later part. But for three hinge, why it is three hinge? You see, there is this point, and this point. It is hinged at 3 points. That's why this arch is called three hinge arch. Okay. So here you see a three hinge circular arc with center O. This is the center. This is the center. This is not the center. Okay, this point is not the center. Remember this. This is a part of this. If we draw a circle, you need to use this as center, this O. Okay, and this radius R is given R. Okay, from the property of a circle, the radius R of the circular arc of span L. This is a span L. This is span L, and rise H. This is the rise H. H. So how we need to find out the radius? You can use this formula. Okay, just remember the formula. We need to use this formula to find out the radius for a circular arc. For a circular arc, if we need to find out the radius r, if the length and rise is given, we need to use this formula. Okay, this formula, r is equal l square by 8h plus h by t. Okay, we are going to use this formula when we are solving a numerical. Just remember this formula: R is equal to L square by 8h plus h by 2. Okay, so after that, what we need to do, taking origin at support A, the coordination of any point D at a distance x from the support is given by. So if we take the support A, this A point, after that the coordination of any point D, here we are considering a point anywhere in the arc D at a distance x from the support is given by. Okay, when we need to find out the coordination at any point in the arch, how we need to find out, we need to use this as formula: x is equal L by 2 minus r sine theta. Okay, and y is equal to r cos theta minus r in bracket minus r minus h. Okay, so here if you take the r common, if we simplify it, we'll count this as your equation, final equation. Okay, after this, for the parabolic arc, if we are considering a parabolic arc, if our stringing points means these points, this stringing points, it is this string, this points. So how we need to find out the equation of the parabola? We need to use this formula. Okay, just remember these formulas: y equal 4hx by L square into L minus x. Okay, when we solve the numerical, you will understand this, how we are going to use this. So in arches, compared to normal beams at any point on the arch, four different types of forces develop. Okay, there are four forces will come in an arch. But are those? One is vertical force, one is radial force, one is horizontal thrust, and one is bending force. Okay, so we are going to discuss one by one, step by step, how we are going to find out this. So in step one, what we need to find out, as we did earlier, first in our step is determination of the support reaction. In the next, use the equilibrium equation to resolve the forces. After that, we need to find out the M and Q. Okay, what is this M and Q? M is your moment and Q is your radial. Q is your radial shear. Okay, radial shear. This N is normal thrust, N is normal thrust, and Q is your radial shear. And there are two formula also. We are not going over the derivation part, okay? That part is not required for finding out this. So there are two formula given, N and for Q. So these two formula we are going to use again to solve this. This formula, N is equal to V sine theta plus H cos theta, and Q is given by V cos theta minus H sine theta. Okay, remember these two formula. This is N and this is Q. Okay, it's look like theta but it is Q. It is Q. Okay, and the above one is N. N is normal thrust and Q is radial shear. Okay, so here's the example. We're going to solve this. So please read the question carefully. A three-hinged circular arc hinged at the springing and crown points have a span of 40 meter and a central rise of 8 meter. It carries a UTL of 20 kN per meter over the left half of the span, together with a concentrated load of 100 kN at the right quarter span point. So what we need to find out? We need to find out reaction at the support. Next, number 2, normal thrust, shear force, bending moment at a section 10 meter from the left support. Okay, so let's go one by one step. So first, as per the question, a 3-hinge circular arc arcs at the springing and crown points have a span of 40 meters. So here you see 3-hinge arc is 1 point, 2 point, and 3 point. Springing at crown, this is your crown. Span of 40 meter, this is 40 meter span is given. Have a span and a central rise of 8 meter. Central rise of 8 meter. This 8 meter is given. This is the rise H, which we already discussed. It carries a UDL of 20 kilonewton over the left half of the span, together with a concentrated load of 100 kilonewton at the right quarter span point. Okay, 20 kilonewton in the left side portion. You will see 20 kilonewton per meter UDL is given in the left, and a point load of 100 kilonewton at the quarter span of the right. Quarter span means half of the right side. Okay, so as per the question, we have already drawn all these strings. So now what we need to do? Okay, first we need to name the point A, B, and C. There is horizontal force and vertical force in each point. These points. Okay, so calculation of support reaction. For that, what we need to use? We need to use the equilibrium equation again. So summation of P. For that, what we need to do? There are two from the below, PA plus PB, and we need to consider the load from the above. I think all of you know how we need to calculate. There is a point load 100 plus 20 into 20 UDL. This UDL. Okay, this is our total. So by taking moment at about any point, say we are taking about B, so VA into the whole length span. I think all of you know how we need to do this. Just use this. From this, you can easily find out the PA value. So if you find out the PA by simply putting here, you can easily say the PB value also. So after that, what we need to do, we need to take the moment about this C point. Here you see, taking moment at C point, we need to find out this horizontal force H by taking the moment about that point C. First, what we need to do, we need to taking moment about B. Here we are taking in this step, we are taking moment summation of MP, and D is equal 0. From here, we can easily find out this PA and PP. One part is above up to this. So our arc is hinged at this point also C. Okay, so now we are going to take the moment about this C and C this. So by taking moment about that point C, if you consider all the loads and all these things, you can easily find out the H from here. Okay, up to this our one part is over. So from here, what we need to find out, after this we need to find out the radius. So for radius, finding out the radius, the formula you already know. This formula R is equal to L square by 8H plus H by 2. So just simply put all the value because everything is given. L you know 40, H is given 8. So just put the value, you can find out the radius. Okay. So after this, what we need to do? We need to find out the vertical shear, normal thrust, and all these things. So for that, we need to consider a point D. This point D. We are considering a point D. Okay. So here, what you see, let D be the point 10 meter from the left support where the normal thrust, shear force, bending moment. We need to find out at that point, since it is a circular arc, See, we are drawing this point here. This is D point. We are considering this D point. It is a circular arc. We have already found out this radius R. Since it is circular, so radius will be same in everywhere. After that, we need to find out the slope. At what slope this point is here. So for finding out this slope, by using this sine theta tan, it is the given distance, r is the radius, so easily you can find out the theta from here. Sine inverse. After this, what we need to find out, we need to all the force, we need to find out here vertical shear at D, what is the vertical forces are coming, what are the horizontal, what are the normal, everything we need to find out. So again, taking moment about this that point, calculation of vertical shear force V, simply V equal to PA minus UTL. PA we already calculated, UTL you can say easily here at a distance of 10, so it's 20 into 10, this 20 into 10. So from here you can find out the P at that particular point. So now we can easily find out the normal thrust. This formula, using this formula, P sine theta plus H cos theta, because we already know P, what is our H, what is our theta. Just put all those values here and you can easily find out what is our N, normal thrust. Similarly, you can also find out our radial shear Q. This is Q, okay? This is Q, radial Q, because everything we know. Just put all the value and then easily find out this radial shear, okay? Please go through once this numerical, read the question carefully and go through the step by step. It's a very simple numerical, just you need to put everything is very simple, just you need to use the equilibrium equation. From using the equilibrium equation, you need to find out the horizontal force, vertical force. After finding out this, you need to find out the radial shear and normal thrust. For that, you need to consider a point, and in that point, you need to find out the normal thrust and radial shear and all these things. You need to find out here.
Hello, sir. Hello, sir.
Okay, Michael.
Please, can you? I understood what you said, but sir, please, can you explain what you mean by that radius shear? Because in third semester we're only doing normal thrust. We didn't understand what radius shear is.
Which one? Radial shear.
Yeah, sir. What do you mean by that? Because before we only do for normal thrust. We didn't do. So please, can you explain, sir? What do you mean by that radius shear?
Okay,
Why do we have to find it?
okay, okay. Just wait for a while. Maybe there's something I can show you. Just wait for some. Okay, let me find something to show you how why it is important. What till then you all of you please go through this numerical. Let's go through this. Hello, am I audible to you? Hello.